we have a look at this question, and you can see I've split the answer grid into no calc and TI Nspire. And for the no calc, we've got a little think about what formulas we have, and we have the general nth term rule formula. It's u of n equals u1 plus n minus 1 times pi d, and this question tells you it's arithmetic. So we just identify the first term, which is the 5, right? There's the 5. So this is the first term, u1. And then we just identify the d. Now the d is clearly positive. It's positive 4. So d equals 4. So with that, we just write down u of n equals u1, replace it with a 5, plus n minus 1 times by 4. And that's it. That is the rule. I mean, you can expand it and tidy it up. So we'll do that anyway. un equals 5 plus, and then it's n times 4. Minus 1 times 4. So the final answer becomes 1 plus 4n. There's A. Now B. I've got to read this carefully. Some people did this the wrong way around. Is 116 a term of the sequence? So basically the 116 is down here, right? And what we've got to understand is that there are, let's put this one, the first term, the second term, the third term, the fourth term. This is 5, 9, 13, 17. So we're saying, will 116 appear here? And if it does, it has to have an n number up here. So we're trying to solve 116. Does 116 appear in the sequence? So we're going to solve this, right? And so we subtract 1. And then we don't even need to do the calculation, because you can see 115 is an odd number. So 115 divided by n, that's right, my bad, 115 divided by the 4, okay, so what's that, 25 is 100, you can get your calculator out clearly, obviously, and do this, 25, 4 4 is 16, 28.75, does that look alright? And that's equal to the n value, all right? So n is this amount, and of course, if n is not an integer, because obviously we have to have the number here, the n value has to be a whole number. So 116 doesn't work, right? 116 doesn't work, so therefore 116 is not a term of the sequence, okay? So we should really write that statement at the end as well, after we've done the written explanation. If we've done the calculation. So this on its own, you've got to be careful with this on its own. Maybe this is good, right? So that's excellent. But if you just have this, you're kind of trusting the examiner understands what your reasoning is. So I think having this is excellent. All right, let's just do the last part, and we'll do this using a non-calculator specific. When will the sequence reach 1000? So we've got the rule here. We've got 1 plus 4n. We need that to be bigger than 1000. So we have 4n greater than 999. And so you've got n greater than, well, 250 will take us there. But if you do 999 divided by 4, you'll get 249.75. So clearly we need n to be 250. So the 250th term, okay, will take us over 1000, okay? So there you go, that's how to do it, probably the normal way, the non-calculator way. But I think it's good to do it with the calculator as well. So let's go ahead and show you the complete calculator way now. So let's go and try and do this same question again, but maybe using the TI Nspire. And the first thing to do is to notice this is an arithmetic. And so we will need to think about what the first term is, what the second term is, what the third and what the fourth is. 5, 9, 13, 17. All right, so I'm putting it down as a table of values. This is n, the position of the number, and this is the u term, the u of n here. All right, so n and u, and then we just go to our TI Nspire and we are going to put in a spreadsheet. We are going to put in n here. That's going to be 1, 2, 3, 4. We're going to put in u, sequence u, and that is the 5, 9, 13, and 17. Fantastic. Then we are going to go doc, insert a data. We're going to plot the data, and the data, the table of values we did. And of course it's linear because arithmetic has got a difference of 4, and so this should be a straight line. Y equals 4x plus c. Menu, analyze, regression, linear, and there we go. Perfect. 4x plus 1. So what we're going to do is we're going to put this equation now into insert a graph, and so we're going to put 4x plus 1 here. Now remember, our equation is 4x plus 1, but we'd write it as 4n plus 1 in any answer, because n is the language of sequence and x is the language of functions. So here we go, we've got this lovely function here, and now determine whether 116 is a term of this sequence. Well, we can control T, turn on the table of values, and we're looking for 116 to appear in the U column, right? And it doesn't. Yeah, but so we can say no, it's not, but we need to have some explanation. And so the best explanation of that is we'll write our answers down now here. A is u of n equals 4n plus 1, right? Don't copy just down the 4x plus 1. B, we can say the 28th term is 113, and u29 equals 117, and we can put therefore 116 is not a term in the sequence, right? It's pretty cool. And then C, we kind of do the same thing, but we're after 1000. Okay, so we're looking for 1000 now. So if we go back to our table of values, we can, my bad, let me just escape that. We can just keep scrolling down the table of values until we get to 1000, which is going to take, quite a long time. So we can try it in 2 different ways, right? Let me show you both different ways. If we control T to turn off the table of values, and now in our graph here, we basically want to know when this graph hits a height of 1000, okay? Now, clearly it's been joined up here, even though we know that we can only have integer values on the x, but this will help us get to 1000. So if I go control G is a shortcut for the graph. If I type in 1000 and press enter, then we should really go and look for the intersection. So menu, analyze graph, and we look at intersection, okay? And we're intersecting on this graph, but we need to see the second graph, right? So we actually do need to see it on screen to find the intersection. So let's go menu, window zoom, window settings. We need the x-min to be 0, and let's do the x-max to be 1000, and let's do the same with the y-min, 0 and 1000. Okay, so there we go, and we can just about see as we grab and move along. So if we can see the section point, we can find the answer, but it's a bit fiddly choosing what kind of scale you need. So menu, analyze graph, intersection, before, after, and look, it says when we get to the 250th term, we've got up to this 1000 mark. But again, this 1e plus 3, right? This is actually rounded off, isn't it? So it's rounded off to only 3 significant figures. So there is a limit to what your calculator can do for you, especially if it's set up in a slightly different way. So I'm going to show you an alternative way now. Control T, the table of values. And basically, I want to guess numbers here that makes this close to 1000. And you can kind of guess that 250 will do it, right? Because 4 times 250 is already 1000 plus 1. So it looks like 250 is an easy answer, but let me show you the calculator way anyway. We go to the menu, and we go to table, and we edit table settings. And under the independent, we go to ask, okay? And then we just put in numbers for x. Well, we got to 401, maybe 200, maybe 300, too much, 250, 2449, perfect. And look, with that, we've got our answer, and we can just write that straight down. We can write down u of 249 equals 997, and u of 250 equals 1001. So we need 250 terms. Okay, so you give full sentence answers. All right, I think a lot of you just didn't think you needed to write words down for your answers. So the key things there for part B was 116 is not a term in the sequence, all right, for this kind of reasoning, and we need 250 terms for part C.